radio frequency identification. Hi, I'm Allison Washington.
Jerry on the fade.
I'm Louis Delgado.
In the ever-changing world of technology, we are being introduced to more innovations advancing our means of business and living than ever before. The development and growth of electronics and telecommunications have played a major role in the imminent success of our business processes. Now more than ever, security has become a key concern in every aspect of business in all industries. Identity theft, stolen credit cards and information, viruses, hackers, and other threats have raised data security, once an arcane topic relevant only to programmers, to high levels of public awareness. Though there are many ways for companies to provide security for this report, our focus will be on the emerging use of radio frequency identification, or simply RFID, and how it differs from the existing alternatives preceding the development, and the security measures that come with it. We will discuss the pros of RFID as well as the cons. We will also identify the threats like deception, manipulation, or misuse of the RF communication between tag and reader. This report also contains control strategies related to RFID, as well as provides you with the background information about the emerging uses of RFID in security. RFID can be tracked back through history all the way to World War II. The first experiments with radio used in this way were conducted by Sir Robert Watson Watt when he invented the radar. The system used a single transmitter receiver which transmitted a high-powered signal, and the aircraft, in the first instances, passively reflected a small amount of radio energy back, which was received by the receiver in the radar system. However, it wasn't until many years later that it began to develop and become incorporated in companies for security. Low-frequency systems were created to track cows, and later low-frequency transponders were also put in cars and used to control the access to buildings. Over time, companies commercialized systems and then moved to the radio spectrum to high frequency, which was unregulated and unused in most parts of the world. High frequency offered greater range and faster data transfer rates. Companies, particularly those in Europe, began using it to track reusable containers and other assets. Today, systems are used for access control, payment systems, and contactless smart cards. However, companies need to be aware of the security risks that come with RFID.
I'll now be speaking about threats to RFID. Basically, we've had several threats to RFID over the previous years. The threats we currently have are RFID Edge hardware layer. This layer contains confidentiality, integrity, and availability. On the confidentiality end, we have the side channel attack. This attack previously engulfs the whole RFID depending on the range we have such tag located. Next, we have the integrity issue. This section contains physical data modification problems, fault induction, impersonation, which includes tag cloning, tag swapping, tag reprogramming, and spoofing. Spoofing of all which is most common in our present day. Next, in this section we have availability. This includes permanently disabling edge hardware, removal of the software within the hardware, destruction of the software and the tag programmed in the hardware, disablement of commands and abuse of commands which was programmed into the hardware. Subsequently, we also have temporary disabling tags, which means it doesn't allow tags within the RFID software or RFID hardware to work. Lastly, we have exhaustion of protocol resources and the synchronization attack. All these are within the hardware layer of the RFID. Next, we'll move on to the communication layer of the RFID. Within the communication layer, we have three basic subcategories, which are also confidentiality, integrity, and availability. Within the first one, we have evades dropping, unauthorized tag reading, privacy threats, which includes tracking and hostilizing. We have key compromise, crypto attacks, reverse engineering, and others. Within integrity, we have relay attacks, distance fraud, mafia fraud, terrorist fraud, replay attacks, message reconstruction, data modification, coding, schema views, data insertion, and racing. Finally, within availability, we have active interface, noise, jamming, misusing blocker tags, passive degradation of signal, frequency detuning, field cancellation, and shielding tags. Now I'll hand it over to Luis Delgado, who will introduce you to how RFID works.
So how does RFID work? A radio frequency identification system has three parts: a scanning antenna, a transceiver with a decoder to interpret the data, and a transponder, which is the RFID tag that has been programmed with the information. The scanning antenna puts out radio frequency signals in a relatively short range. The RF radiation does two things. It provides a means of communicating with transponders, and it provides the RFID tag with energy to communicate. This is absolutely key part of the technology. RFID tags do not need batteries and can therefore remain usable for long periods of time, maybe even decades. The scanning antennas can take whatever shape you need. For example, you can build them into a door frame to accept data from a person or object passing through. When an RFID tag passes through the field of a scanning antenna, it detects the activation signal from the antenna. That wakes up the RFID chip and transmits the information on its microchip to be picked up by the scanning antenna. In addition, the RFID tag may be one of two types, which is an active RFID tag or a passive RFID tag. Active RFID tags have their own power source. The advantage of these tags is that the reader can be much farther away and still can get signal. Even though some of these devices are built to have up to a 10-year lifespan, they have limited lifespans. Passive RFID tags, however, do not require batteries, and they can be much smaller and have virtually an unlimited lifespan. The RFID tags can be read in a wide variety of circumstances where barcodes or other optically read technologies are useless. The tag doesn't need to be on the surface of the object. The read time is typically less than 100 milliseconds, and a large number of the tags can be read at once rather than item by item. In essence, that's how RFID tags work. So some of the advantages of RFIDs are that they're effortless when checking out. You can have all your items in a basket and walk out the door of the grocery store rather than checking out. They're cheaper than barcodes, only 7 to 20 cents per RFID. Once everybody adapts to the RFIDs, they're should be going down to about 5 cents per RFID tag. And also they can scan up to 25 times faster than a barcode reader. Also, they can be read from further distances, up to 300 feet as a matter of fact. Like any other technology, there are pros and cons associated with the RFID, most notably concerns from a security aspect. A major flaw concerning RFID is that it does not have the computing power to encrypt data. This presents a personal privacy concern due to the risk of unauthorized data and alteration of tag data. Unprotected tags are vulnerable and subject to things such as eavesdropping, traffic analysis, spoofing, or denial of service attacks. The more RFIDs are becoming known as the new method of transactions and processing data, the more hackers are becoming sophisticated and finding new ways to read credit cards and other confidential information through clothes and wallets. And now I'll hand it over to Allison for the conclusion.
Though it is evident that there are security concerns that need to be addressed, RFID is still believed to be the next generation of information identity for retailers and other industries, just as any other technology on the rise. RFID will require time for growth and development in order to become perfected. Nevertheless, more and more top-tier corporations and even countries are investing in the new technology for various uses. With the expansion of RFID and enhancement of its security, we will be seeing RFID become more standardized in years to come, not only in the retail and manufacturing industries, but also in the military, government, and other industries. Thank you.